Hi, everyone. This is Michelangelo. First of all, thank you for setting up this community day. I really enjoyed the concept, and I've been watching it throughout the whole afternoon. So thank you. The session of today, Cloud Native by Design. Basically, this talk came about when I was looking at clients of mine that were moving things into the cloud and actually were not using the cloud infrastructure to the full potential. So that's why I decided to create this presentation about it. Of course, vanity slides. If you go to my Twitter account, which you will find down below, you will see the same message. So let's get started. I come from a background of PHP, and for us, everything that we built was built on top of the LAMP stack. LAMP stack is the acronym for Linux, Apache, MySQL, PHP. As most other technologies also adapted it for Perl and Python. But the general idea was to have PHP as the main technology there. And of course, when you have a LAMP stack, you have your application logic built with PHP is combined with an Apache web server, MySQL database, often run on OS being Linux, and yeah, you have a virtual or a physical server underneath. But this whole approach was good back in the 90s, but when you were looking at increased traffic or yeah, more users on your system, it was also the single place where things started to fail, and the complex systems that were built, the monoliths of those days, were not able to be modified easy. So we needed to have a different approach on this. Of course, attempts to scale, the single stack application scaling has been tried for a number of years, and we started off with we have a LAMP stack, and then we scale it even further into multiple LAMP stacks. As you will know, this is not really a good solution. First of all, there is no synchronization of data. Your sessions are going everywhere, and yeah, there's no control over where your data is flowing to. Over the years, people decided, like, okay, we need to tear it apart and build a more robust architecture. And this more robust architecture had the form of, hey, we put a load balancer in front, we have multiple web servers, we have a process manager, which we also now see with nodes, for instance. We provide a caching layer in between our data store and the file system and our application logic. And this actually allowed us to scale our applications more in terms of getting better performance, handling more load, and those kind of things. But as we were moving towards the virtualization era of server management, tools like VMware, VirtualBox, Xen allowed us actually to create these very complex setups, because as I mentioned earlier, LAMP stack was just a single stack on a single system, and now we had to have multiple systems. We need to have multiple network interfaces and those kind of things. And it was becoming very expensive. Thanks to the virtualization solutions, we actually now had the ability to create the same setup with less cost. Of course, the clouds were also coming, and yeah, we had the default cloud like AWS, Microsoft Azure, and Google Cloud that provided like, hey, here is a suite of services and tools you can use, and you can build it your own. And then you had services like DigitalOcean, Heroku, Rackspace that provided like, hey, here you can have like predefined setups for your common application structures. And this allowed businesses and developers to scale up their applications very quickly. The only problem is that, hey, now I have all this virtualization in the cloud, and I have a massive amount of performance in the cloud, but I need to develop this, and I need to develop this locally, and I'm still stuck with my single LAMP stack kind of approach on my workstation. So Vagrant came along and actually provided a enormous solution, because it provided simple management for virtualization locally, but it could also manage your servers and also your cloud infrastructure, which gave it a whole lot more potential. So for the development part, everything was now taken care of, except for we're still building massive amount of applications, still trying to utilize as much logic as possible. And in the end, we were pushing up monoliths uphill, which were very, very hard to maintain and to take care of. Docker came into play, and it became like the massive game changer. Everything that we had learned about building applications was now redesigned and rethought, and a new term came along, was being called microservices. So now we needed to create single-purpose applications, single-purpose objects, and that allowed us to basically get the information out there. And one of the main constraints on this was API-driven design. With API-driven design, you had the ability to provide an interface between your components, so they were not completely tied to your logic, and allowed you to scale very rapidly. One of these architectures became like very loosely coupled components, where you had a single purpose object, and that single purpose object was able to provide necessary interfaces to combine other objects to build your complete logic. So the monolith landscape started to be torn down, and microservices came into play. But along with microservices also came other challenges, and the complexity of tracking all these services and converting the server management into like herding cattle was one of the major constraints in managing these microservices. Also, compliance and regulations, security had issues figuring out how to secure all these components. And also, for developers, the idea of single purpose objects was very challenging. So what we saw after a few years of microservices is that microservices became like, hey, we have VMs, either containerized applications or complete VMs running single purpose components of an application. But we're not actually leveraging the whole cloud infrastructure as it should have been done. I think that with the rise of Kubernetes, the orchestration and the management of all these containers became a lot easier, especially in regards to, hey, I want to have my application being torn apart into multiple containers, and each should have their own single purpose. Kubernetes was a major game changer in that effect. Of course, all the major cloud providers adopted Kubernetes as a first-class citizen in their infrastructure. So now Kubernetes is supported by all major cloud providers you can think of. So cloud native design is really about unleashing the full potential of the cloud as a whole, and not just the containers and the Kubernetes setups that I've been talking about. We want to have the full capacity of the cloud, and we want to make it useful to our advantage. So first of all, we need to design for automation. People have been talking about infrastructure as code, using automated provisioning tools like Ansible, Chef, Puppet. But it's one of the mandatory components that if you build for the cloud, you need to be able to script it and be able to repeat it multiple times over. So you have like always the same setup every single time you execute. Also, having continuous integration and continuous deployment pipelines are a mandatory component when you go to the cloud, because you need to be able to make sure that whatever is being released meets your quality standards. But also, when you have something that needs to be fixed immediately, you should not be worried about all the manual steps that need to go through. It should be an automated pipeline that will take your changes and move it to the cloud. Another aspect in this whole cloud approach is that you need to design for failure. Most often I see people building very nice applications that run perfectly on the cloud, but when something goes wrong, like there is an outage somewhere, the whole application grinds to a halt or is not even responding. So designing for failure is one of those traits that a lot of developers need to learn when they are building applications for the cloud. Tools like Netflix, Chaos Monkey, and Fever, and all the other tools are there actually to help you figure out, okay, what can go wrong in a cloud environment, and how can we protect ourselves against it. What we call the state of an application. The state is really a mandatory aspect of your cloud infrastructure, and event sourcing, CQRS are the techniques that help us provide the state, especially in a highly distributed architecture. So if you are very eager about maintaining state in your applications, go check those concepts out. They're very interesting. And one of the most critical parts of your cloud infrastructure is the idea of managed services. Managed services are probably the best way to make use of the cloud, because all you have to do is provide your own logic, and the vendor or the cloud provider will take care of the services underneath it. The biggest challenge in there is, hey, yeah, we don't want to have a vendor lock-in in the applications, which is a fair argument, but since most of these services, especially if you select those services correctly, are based on open technologies, the amount of vendor lock-in that you will have is pretty much reduced, and you will have all the benefit of the cloud vendors' infrastructure as much as possible. We ourselves were looking at platform as a service or software as a service as much as possible, because it allows us to focus on our application logic and not on maintaining the underlying infrastructure to run it. And also defensing in depth. We had already a couple of sessions here talking about how you can lock down your environments using identity management. You can use the private IP configurations and so on. Just make sure that all the complexity that you build in your application provide like an additional layer of security, which makes it a lot more difficult for people to actually get into your into your data, which is ultimately the best kept thing that you want to secure in your environment. And as you go to the cloud, of course, it's a never-ending story. There is not a single project that is ever done when you move to the cloud, because you always have changes on the side of your cloud provider. Can happen even daily, and also your own application grows as you proceed in time and move forward. So always improve, always simplify, and optimize where possible. One of the Biggest challenges is defining that business goal. The first question you need to ask is my cloud going to provide me uh, a step closer to reaching the business goal? Um, I see a lot of people deciding, hey, we move to the cloud because it sounds trendy, or it looks good on paper. But if it's only for like, hey, I need to have like a small application that will only be used internally, maybe the cloud is not the answer for your needs. Um, so you really need to balance the idea if it meets your business goal. Second of all, choose your technology stack. With the cloud, you have an opportunity to select whatever kind of technology that you want. Um, just be aware that if you choose a technology stack, you also need to provide people that have knowledge about this technology, and you need to be able to maintain this technology for years to come. So even though it might be great to try out the latest and greatest, if you're building something long term, you might want to go back to the more classic technologies, or keep a single stack technology. That would be recommended. Once you have decided your technology, you need to find a cloud solution that works with your chosen technology. To give you an example, I'm building PHP applications, and if we want to build PHP logic, we can use app services, but we currently cannot use functions at this point. Maybe we can convert some of this logic into Node or Java or C Sharp, but PHP no longer is being supported. Although I have to still look into this, things might be changing on that front. But of course, when you have decided on your technology, choose the solutions matching your knowledge and your capabilities on that term. Maybe it's trivial for most, but define what kind of KPIs and SLAs you want to provide with your cloud solution. Most often I see people moving to the cloud, and they have users on their applications, and then they ask, oh, when can we do like a upgrade? And they don't even know how many users are constantly using that solution. So you need to be sure that you know your objectives, and also what kind of indicators you have that will provide you more insights in, okay, how am I going to form my service level agreements. And when you have completed these steps, you can go ahead, start designing your ideal cloud solution, and hopefully it will meet your business objectives. And yeah, the ideal cloud solution is not a one size fits all. So every business out there has a specific requirement that needs to be challenged and developed internally. Last but not least, you need to monitor a lot. Uh, there are a lot moving components in your cloud environment. And if you have no idea what's happening, yeah, things might go wrong without you knowing it. So at least have your KPIs and your SLA components in monitoring, but also the default service monitoring set up, which can be provided inside the cloud or yeah, using a third-party tool like Grafana or something like that. That was the theoretical stuff. I was thinking about, okay, how can I make this more tangible? And I was looking at WordPress. WordPress is probably known by many of you as a PHP blogging application. So let's make a WordPress cloud scale. Well, according to WordPress website, it's taking about a third of internet traffic. So 30% of all the websites are based on WordPress, which is like a third of the internet. But if we look at how WordPress is built and how it's being provided by many hosting providers, nothing has changed in the past 2 decades that in existence. So I still see WordPress being one single application on top of a PHP stack that runs on a web server, has a MySQL database behind it, and runs on an operating system running on a virtual or physical server. And then I go look at how people are scaling WordPress applications, and I see, oh, we have a load balancer, and we have one instance of WordPress and another instance of WordPress, and we have a MySQL database behind it, or a MySQL cluster behind it. Yeah, it's a scalable WordPress, but in my point of view, it's like my first example where you have like multiple lamp stacks nicely set aside with each other. So I want to look more at how can we really scale WordPress. So this was not actually a solution for me. Let me introduce you to WordPress API. WordPress comes with a REST API out of the box, and not a lot of people are aware of it, basically because it's not really advertised that much. But it does give us a lot of more opportunities. So if I look at a loosely coupled design, I have a load balancer, and I have static websites that could be on a file system storage. I have my application gateway, which is like an API manager, and I have my WordPress backends and my database cluster. And all of a sudden, I now have more potential to scale it up or down in the front and not sincerely in the back. So if I go to our website into it.be and I go to the API endpoints, I can get the JSON data directly from the website, which makes it a lot more easier to integrate it with applications like JavaScript, building React websites, Jekyll websites, Vue websites, and so on. So it gives us a lot more potential to separate the front and the back from each other. Um, yeah, another advantages is, well, first of all, static pages are static. So whatever you want to do, there's not a lot of hacking you can do there. Static pages are also serving up to 40 times faster than any other kind of rendered page. You can have A/B testing very easily integrated there, and all of a sudden you have the ability to scale indefinitely as long as you have like storage availability. So let's have a look at a proof of concept. My proof of concept, the source code can be found here. I will provide the link to the slides at the end, so don't worry if you don't catch it right now. So my setup is basically a WordPress with Nginx front server for serving the static pages, Nginx gateway, which provides like a gateway interface for the API of WordPress, WordPress itself, which is a vanilla install. Just go to wordpress.org, download, and done. And MySQL database. If I spin it up, I have a very common looking blog entry. I can even get the API data, and I can build my front end statically. Of course, I'm not a designer, so this is my best effort to create something useful. And now that I have this set up locally, I want to take it to the cloud. So how does it work? Well, if I look at Microsoft Azure, well, we have a lot of opportunities there. First of all, you have the MySQL database cluster available. You have an app service that can run WordPress out of the box. You have your blob storage that can serve static websites. You have an API manager with a Redis cache, so you can even cache the requests in transit and so on. If I look at this setup, my environment is also completely secured, so I can only reach it through a VPN tunnel. So no malicious actor can actually access the backend system. The only access that they can possibly get is at the API manager. So when I run this in the cloud, I get the same results, and with a little bit of Bootstrap flavor on top of it, I can actually run this as well. When I look at WordPress, WordPress is good for blogging, but it's also good for e-commerce. WooCommerce is probably the most used e-commerce plugin for WordPress. So it allows you to have your electronic store being displayed directly, and through the API you can have your sales funnel completely automated and separated from the backend, which gives you a lot more security and performance. And I think especially for e-commerce, it's really a benefit if you have fast loading, fast processing websites. WordPress is not the only one that actually has this feature built in. You can use it for Magento, Suite CRM, and Drupal. So even for content management sites like built with Drupal, you now also have a REST API to to provide this architecture, and gives you a lot more power to distribute it. So let's wrap it up. Decouple your application components by using APIs, and thankfully in PHP world we already have this built in most of the applications. So for us it's really an advantage. We use infrastructure as code to set up and orchestrate the desired architecture. So we can automate it and repeat it as many times as possible. Think about scalability, security, testability in your architecture design. So design for failure and test for this as much as possible. And never stop optimizing your architecture. A couple of references I do want to provide you. Cloud native patterns, cloud design patterns, cloud architecture patterns, and designing distributed systems are key resources you might want to have a look into. As I said, I have the links to the slides right here, and I will take some questions.
There don't seem to be any questions. People, if you're watching online, use the chat to ask any questions, and we'll forward it to Mike.
Mike, maybe a question from my side. You mentioned that you're deploying using infrastructure as code. What exactly are you using as a solution?
I'm using Terraform as a solution.
Okay.
So the infrastructure is set up with Terraform, and having the code being pushed on it using ACE copy command makes it easy for me to copy the source files on the storage and the source of WordPress onto the app service. And all the rest is configured through Terraform using the configuration for CDN, for VPN, all the other stuff.
Okay, cool. Yeah. I think if there's no further questions, we can wrap it up here.
Right.
Yeah,
Thanks a lot for your session.
Well, thank you for having me. I hope it was interesting.
Absolutely. Everyone watching online will be back in a good 15 to 20 minutes. And Mike, if you want to hang around in the YouTube chats, feel free to do so, because there may be questions popping up afterwards.
Okay. Yeah, I just see one popping up, so perhaps you want to check that out. Oh, wait. It's by Juan Pedro. For managing multiple sites, do you deploy WAF as part of the infrastructure? One-to-one is the question.
Well, if I go back to my slides, this one. In this case, I don't have a web application firewall set up. And my application, my API manager is basically the controller to make sure that I configure my endpoints that I want to expose from WordPress in such a way that I control, okay, what gets accessed and what not. So the need for a WAF in this case is not necessary. If you're using other applications where you don't have the ability to create static content in front of it, a suggestion would be that you have at least a firewall with a WAF in front of it, preferably after or before you get into load balancing multiple sites.